Good afternoon, students. I hope I'm audible. We'll start with attendance. Attendance Martin,
Present, Miss.
Svetak, Abhishek,
Present, ma'am.
Aditya,
Present, ma'am.
Aditya,
Present, ma'am.
Aghosh,
Present, miss.
Aida,
Present, ma'am.
Alan,
Present, miss.
Albino,
Present, ma'am.
Alina, Alfigo,
Present, ma'am.
Alna,
Present, ma'am.
Alfonso,
Present, miss.
Amal,
Present, miss.
Amit,
Present, ma'am.
Angelina,
Present, miss.
Anne Maria,
Present, ma'am.
Anto,
Present, ma'am.
Anuvind, Ashin,
Present, miss.
Ashwati,
Present, miss.
Iona,
Present, miss.
Benhur,
Present, Miss.
Christy,
Present, miss.
Derek, so I don't want you to listen to music while you're attending the class. So if you are doing that, please switch off that music device, whatever it is. Devika,
Present, miss.
Dhanush,
Present, miss.
Dheeraj,
Present, miss.
Tiruraj,
Present, Miss.
Dia,
Present, miss.
Edwin,
Present, ma'am.
Fatima,
Present, miss.
Gopika,
Present, miss.
Gopika,
Present, miss.
Haripriya,
Present, miss.
Jasira,
Present, miss.
Jeffin,
Present, miss.
Jimilt,
Present, ma'am.
Joe,
Present, ma'am.
Johnny,
Present, Miss.
John,
Present, ma'am.
Jocelyn,
Present, miss.
Liz Maria,
Present, miss.
Manav,
Present, miss.
Mayuka,
Present, miss.
Melvin,
Present, miss.
Midun,
Present, Miss.
Namit,
Present, Miss.
Nandana,
Present, miss.
Nayan,
Present, ma'am.
Pavitra,
Present, miss.
Pradul,
Present, ma'am.
Rahul,
Present, Miss.
Prinshaw,
Present, miss.
Sayanth, Sean,
Present, Miss.
Tony,
Present, miss.
Indrajit,
Present, ma'am.
Vishnu, Vishnu,
Present, ma'am.
Vaishnavi,
Present, miss.
Yadu,
Present, ma'am.
ഹലോ മിസ്സേ
who's that?
മിസ്സേ വിഷ്ണു സിക്ക് നെറ്റ് പ്രശ്നമായോണ്ട് അറ്റൻഡ് ചെയ്യാൻ പറ്റുന്നില്ല പറയുന്നത് എച്ച് ടൈപ്പ് ആണ്
Ah,
Ma'am,
Yes.
ma'am, present Vishnu.
Vishnu same. Okay, fine.
Is 45%. Yes.
Midun,
With
Midun, okay. Hello? Name.
63% present ആണ്
Swet,
ശ്വേതർ
Miss Alina present ആണ്.
okay. Svetak is present. Alina, okay. Then did I miss anyone? And okay. So I have enabled the attendance tracker also. So don't leave in between. So today we'll start with module 2. Actually, programming is also part of module 2, but that part you are having for the exams. So I hope the PPT is visible for you. So just a second. Now, you already know what happens when we have assemblers, right? What is the purpose of an assembler? What does an assembler do? You can unmute and speak, or you can message in the chat. What is the task of an assembler? Why no response? You don't know what is an assembler? Still no response. Okay. Go bigger saying it is converting high level language to assembly language. And Nandana saying translates assembly language program to machine language program. Which one is correct? Yeah, Dinuraj, assembly language into machine language. Gopika, it does not convert high level language to assembly language. Assembler converts from assembly language into the machine language. So it works for low level languages because assembly programs they are low level. Okay. So as the name indicates, assembler converts from the assembly language into the machine language. Now, which is the converter from the high level language to low level language? Which are the converters for that? If I want to convert from high level language into a low level language, give me some examples for that. Aditya, okay, compiler, Jasira, compiler, okay, Dinuraj, interpreter, okay, fine. Yes, Maria is also correct. So we have the translators, that is assembler, we have the interpreter and the compilers. Okay, so that part you already know. Now we need to translate. So because this is assembler, we will not talk about compilers anymore in this subject. We will have the first thing, that is the source program. Okay, so source program which is actually written in assembly language. So assembly language means they are written in mnemonics. Now that will be given into the assembler. Okay, the output from the assembler would be an object code. Now tell me what is the next system software that needs to be used? Which would be the next system software? Yeah, linker. So you need to have a linker. Okay. So the next thing that needs to be there is a linker. So it will go into a linker. Now what is the purpose of a linker? What does a linker do? Or what is the output from the linker? The output from the linker is, yeah, exe file. Okay, correct. So I hope you remember that part. Linker is required to create that exe file. And there might be modules or libraries that we use. So here we'll be having some libraries. Okay. And there might be other modules that we are using as part of this program. So again, object code from there also. So all those are linked together to create that exe file. Okay. Now what is the next system software that we need to use? Yeah, loader. And what is the purpose of a loader? What does the loader do? Yeah, loads program to memory. So you need to execute it. In order to execute it, we need to bring it to the memory. So we need to have a loader, and loader will be giving that program or taking that program into the memory for execution. Then the operating system will give control to that program so that it can be executed by the CPU. Okay, so that is what happens. Now, we know that the assembler has to convert the mnemonic operation codes, that is the assembly code, into the machine language equivalents, because that is the only language that is understood by the system or the machine. So again, we need to assign machine addresses to symbolic labels. We might have used, say, JSUB RDREC, read record. So this is a symbolic label or a symbolic operand. So this has to be given an address. So we have to assign machine addresses to the symbolic labels. So those are the two fundamental functions that should be done by an assembler. And you know that low-level languages, they are machine dependent. So assembler is also a system software that has many machine dependent properties. That is, it would depend upon the machine instruction formats and the machine codes. So those are the features for or fundamental functions for the assembler. So basically the assembler has 5 different functions. That is, it has to convert the mnemonic opcodes to machine language equivalents. Then it has to convert the symbolic operands to their equivalent machine addresses. Then we have for SIC, because it's a hypothetical machine, we have a format by which it has to create that object program. So it has to build the machine instructions in that given format. And it has to convert the data constants to internal machine representations. And it has to write the object program and the assembly listing. So assembly listing means it has to write the source code in the assembly language, and it has to create the corresponding machine code. So it has to print this, that the machine code and the source code in assembly. So convert mnemonic operation codes to their machine language equivalents means, suppose it has STL. We might have written in our programming language like STL is the opcode, but that is not understood by the machine. So it has an internal representation, say 14. So it has to be converted into that internal representation. Okay, because this code has to be converted into the representation. So this is in hex, which has to be converted into the machine language representation. So it would be what? 0001 0100. That is our machine representation. Then symbolic operands to their machine addresses. So wherever, say I have said RDREC. So suppose RDREC is in 1000, then that location value has to be used. And we have to build the machine instructions in the proper format. I'll tell you what is the proper format in a bit of time. And we have to convert the data constants like EOF, that is end of file. It has an internal value, that is 4F4. F46, 454 F46. So that is the hexadecimal number. So EOF has to be converted to this number. Okay. And you have to write the object program and the assembly listing. So I hope you have understood the assembler functions. So write this. If you have any doubts, you can ask. Otherwise, write the note. This is an important short answer question. What are the assembler functions? So after you complete the note, let me know in the chat. If you have any doubts, you can ask. Please let me know after you complete it. Just a second. Again, I am having some issues from my end. Not able to access the PPT. So stay here just a second. So I hope now it is visible. Actually, I was not able to access my PPT. It is okay, no? Okay, thank you for the response, Nandana. So we will move on. So I have already told you that these are the different symbolic, the functions for the assembler. So now we'll see that all these functions except the second one, it cannot be done by using sequential processing. That is, line by line translation cannot be done only for the second one. That is because of something called as forward reference. So we'll see one example for that. So only this task cannot be done in a sequential manner. Okay. So for that, we'll see one example for that. So here you can see that I have the symbolic labels, that is first STL, and I have one RET ADR, which is a symbolic label, and it's just a label. So RET ADR is here. Now, according to the function, you need to convert that symbolic operand into the equivalent machine address. Okay. So when you see STL RET ADR, the machine does not know where RET ADR is. Okay. Because RET ADR is not yet defined. It is defined later. Okay. So you need to give an address for this RET ADR, which is not yet known. So that is called as forward reference. So it is a reference to a label that is defined later in the program. So here you can see that RET ADR is here, but in order to give the address for this, it is not yet seen. So it is not possible to give address to that RET ADR. So that is called as forward reference. Is it okay? So that is why sequential processing cannot be done. That is, line by line processing cannot be done for the second task. If you have understood, please message in the chat. Again, this is an important question for short answers. What is forward reference? Is it okay? Okay, Yadu, Benhar. What about others? Okay, Sean. So I hope you have understood what is meant by forward reference. So you are referring to a label that is defined later. So just note down what is forward reference. Just write the sentence in your notebook. So they might ask you what is forward reference. So this is an example for that. Okay. So we will see that is anyway the assembler has to do all these 5 tasks. So in order to do that, we have one SIC assembler which makes 2 passes over the source program. So 2 passes is nothing but 2 scans over the source program. You scan for the first time, that is, you just scan the source program for label definition and you will assign the addresses. So that is the original task of the assembler, is that you have to convert that assembly language program into an equivalent machine language program, right? So assembly language program has to be converted into the machine language program. So here you need to translate, but here what the assembler does is it scans the source program and it will check for the label definition and it will just assign addresses. So no translation is done in the first pass. In the second pass, it will actually translate. Okay, so actual translation is only done in the second pass because the program might have forward references, so it won't be possible to assign addresses in the first pass itself. So you need to scan the program once again after all labels get the addresses, then only translation can happen. Okay, so that is why we need to scan the program twice. So I hope you have understood why two passes are required. If you have understood, please message in the chat. So two passes means two scans. Okay. Okay, Sean is okay with it. What about others? Okay, Aditya. Okay. So please write this in your notebook. So because of forward references, you will have to scan the program twice. So just write the note. And do let me know after you complete the note. Okay. So you have completed. So just a second. So now I have told you that we need to create an object program, but it should be in a standard format. So this is the format that is followed by SIC machines. You have a header, there's a header record, then we have a text record, and we have an end record. So these are the three records that needs to be created for that object program. Okay, so first we'll see what is meant by the header part. So first column, it needs to be H in order to indicate that it is a header record. Then we have column 2 to 7. 2 to 7 would be the program name. So I have shown you yesterday how to write program. So it might be copy start 1000. Okay, so this is the name of the program. So 2 to 7 should indicate that. Then column 8 to 13 should be the starting address. Say if I have given 1000, that 1000 should come here. Then column 14 to 19 should be the length of the object program in bytes. Okay, so what is the length of that entire program? That should be indicated from column 14 to 19. So please write this in your note, the header file, the header part of the object program. And let me know when you complete it. And you have to study the format of the object program. So don't forget the column numbers. You have to by heart it somehow. So please let me know after you complete the note. Okay, Mayuka. Okay, Dhinuraj. Okay, fine. So that is the first part. So object program will have the header part first, not the header file. The header part of the object program. Next, we'll have the text record. So it will again have T to indicate that it is the text record. Now you might have many text records in the object program. Okay, so one object program will have many text records. So you need to specify what is the starting address in this record. Okay, so where you are starting the text part, that has to be specified. So here also column 2 to 7, it is the starting address. Okay, then column 8 to 9 is the length of the object code in this particular record. So we'll see one example for that. So column 8 to 9 should be the length of the object code in this record, and column 10 to 9, that is the actual object code. Okay, so what is the object code in this record? It comes in column 10 to 69. So when it is a that's a third format, a 3-byte instruction, you will have up to 10 instructions in one record. Okay, in one text record, you can have 10 instructions. When it is a format 3, that's a 3-byte instruction. So that is the text record. We'll see end record also, then you can write. So next is the end record. So column 1 should be E. So column 1 is E here, and column 2 to 7, that is the address of the first executable instruction. So I have given first copy start 1000. So first would start from 1000. So this should be the end record. That should come as part of the end record. Okay. So that is the format of the object program in SIC machines. So I hope you have understood it. So please complete the note. You have to study the format of the header, the text, and the end record. You will have questions like write the object program format. Or they might ask you what is the format of the header. So do let me know after you complete it. And remember, everything is in hexadecimal. So we'll see only hexadecimal numbers. We don't have to worry about the internal machine codes. So Devika has completed. Okay, Johnny. Okay, Alfonso, Dinuraj, Mayuka. What about others? Okay, Rinsha. I hope everyone has completed it. So now we'll see the example for that. So here you can see that this is my header record. So this symbol, that caret symbol that you see, that is just for your understanding. It is not part of the object program. So first column 1 should be the header record. Now you can see that column 2 to 7 should be the name of the program. So we have copy, then the length and the starting address. So we have seen the starting address and the length. So it would be given here. Okay. So next is the T, that is the text record. Then what is the first address of the first instruction in this particular record? Then you have the length of the instructions that is given in this particular text record. So here you can see that there is 1, 2, 3, 4, 5. 5 text records are there as part of this object program. So the length of records given in this particular text record, that is given in the next part. So now we'll see how it is done. So I hope you have understood. This is my header, this is my text. So now we'll see one example for that. So here you can see this is the original program. So here you can see that the name of the program is copy, then copy start 1000. So the first executable instruction is starting from 1000. I have STL RET ADR. Okay. So this is actually forward referencing. So RET ADR is somewhere here. So after the first pass is done by the assembler, every symbols will get its own address. So here you can see that the symbol is, the address of that symbol is 1033. So that is why 1033. And STL, the internal representation for that is 14. So here the object code corresponding to this particular statement would be 141033. Okay. Have you understood? Have you understood that much? Why no response? You didn't understand? Okay, Melvin. What about others? I've only talked about this first line, STL, that is 14. RET ADR, the address of RET ADR is 1033. So that is why 1033. So the object code corresponding to that first line would be 141033. Again, no response. You didn't understand this first line? Then we'll go back to the object program. Should I repeat it? I'm audible, no? Okay, Dinuraj. What about others? I need to know whether you people are there or not. Namit is fine. What about others? Okay, Derek, Rinsha. Okay, so we'll see only the first line now. So the first line, you can see that the object code corresponding to that would be 141033. Okay, so likewise, the other statements are also converted. So we'll come to that later. But anyway, I have told you that if it is a format 3 instruction, you will have 10 instructions in one object code. So this is the first one, second one, third one, fourth, 5, 6, 7, 8, 9, 10. So till here, it would be one object record. Okay, I mean one text record. So here you can see that it has started from 141033 and it is ending with 00102D. Now see here, it has started with 141033 and it has ended with 00102D. Okay? Is it okay? So they have just written it one after the other. That is, after 141033, it will be 482039. So it would be 482039. Then it would be 001036. So it would be 001036. Because for LDA length, the object code corresponding to LDA is 00 and length is at 1036. Is it okay? I hope it is okay till here. So do let me know if you didn't understand. So we'll have 10 instructions in one text record. Now we need to, so this part is over, right? So this part is over. We have 10 instructions. Okay. This is the first address of the first instruction. So here you can see that the address of the first instruction in that particular text record is 1000. So here it will be 1000. Now we need to have this part. So now the address of the first one, that is 1000. You need to subtract it after you have, that is 10 instructions are there. So till here I have completed. So after I give the this much, after updating that much, this would be the address, right? So I'll have to subtract 101E minus 1000. So that would give me the length, right? So 1E. So that is why it is 1E here. Is it okay? Have you understood? We are doing hexadecimal subtractions. Why no response again? Have you okay. So Nandana is asking me to repeat it. Okay, fine. So just a second. So we were talking about object programs, right? So we'll have 10 instructions in one record. If it is a 3-byte instruction, 10 instructions can fit in one text record. Because you can see that actually the length is from the column 10 to 69. So it is like this. 69 minus 10 plus 1, and one 3-byte instruction would take 6 columns. So that is why we will have what, 60 by 6, that would be 10 instructions. That is why I am saying 10 instructions would fit into one text record. Okay, if it is a 3-byte instruction. So here you can see that I need to have 10 instructions. So here you can see it is starting from here. So this is the first instruction, second, third, fourth, fifth, sixth, 7, 8, 9 and 10. This would be my 10th instruction. Okay, so this will fit in one text record. So here you can see that 1000 is the starting address and you are just writing the object code as it is. So here you can see 141033, then you have 482039, that is my second one, then 001036, so that would be my third one, etc. So it has gone up to the 10th instruction, that is 00102D. Now I need to find the length. In order to find the length, I need to take this one, right? I need to subtract. So in order to find what is the length of this, I need to subtract what? So till here I need LD3. Still here I need to subtract. So in order to find the length, I would do what? 101 E minus 1000 only, right? So that would be the length of this one. So it is 1E. So that is why 1E is coming here. Is it okay now?
Yes, ma'am.
Okay, what about others? Okay, Namit, Liz, Maria. Okay, so that is how you calculate the length. Now you need to do the for the next one. So here you can see that the next text record would start from here. It has gone only till here. Okay, remember that for these assembler directive, there are no corresponding machine instructions. They are just directions for the assembler. So you will not have any machine representation for this one. So next text record has come from here to here. Okay. Now tell me what would be the length for this one, for the next text record. Tell me what would be the length from till here. It is first text record. So this till here. That is the first text record. For the next one, what would be the length? You need to do hexadecimal subtraction. So after doing it, let me know. What would be the length for the next one? So only this much has gone into the next text record. So tell me what would be the length after doing hexadecimal subtraction. If you have got the answer, you can message in the chat. Again, I'm not seeing any response. Have you got the answer? What would be the length of that much records? I hope you know hexadecimal subtractions. Okay, I will tell you what you need to subtract. Then you tell me the answer. So this is the starting for this text record, right? 101E. It has gone up to here. Okay. So after writing this into the text record, the address would be what? This. So I'll have 1033 minus 101E. Now tell me what is the answer. Yeah, Yadu, yeah, correct. Albin also correct. Yeah, Sayan. Okay. So it would be 15. Why? When you subtract it, it is actually what? I need to borrow from here. I am telling you the hexadecimal subtraction if you don't remember it. So I have, when you subtract it, we need to take from the base. Now, what is the base of hexadecimal numbers? What is the base value for hexadecimal numbers? Yeah, that you know it is 16, right? So when you subtract it, what you have to do? You have to take from the base. So it is actually we are borrowing 16. Okay. So now when you subtract it, it is actually what you have. What is the value of E and what is here? So it is 19 minus 14, right? So that is why you'll have 15. So here you'll have 15. Have you understood? So for borrow, it will always be dependent upon that base. Is it okay? Okay. So now we'll see, told you already that you need to have a two-pass assembler because it is having forward references. You cannot translate everything in a single pass or a single scan. So you need to have two passes. So these are the tasks done in pass one and pass two. Okay. So pass one, I have told you that it would just assign addresses. Actual translation is not done in pass one. Pass two is where you actually translate it to your assignment machine code. So pass one means you have to assign addresses to all the statements in the program, then save the values for all labels for use in pass two. You will be saving the values assigned to all labels. So for that, we'll be using something called as a symtab. That's a symbol table. Then you need to perform some processing of assembler directives. I've told you for assembler directives like this one, there is no equivalent machine instructions. They are just directions for the assembler. So these are the tasks that are done in pass one. And pass two means you can assemble the instructions. Then you need to generate the data values defined by byte and word. That is what is the character, what is that integer constant, etc. That has to be done. Then perform some processing of assembler directives that is not done in pass one and write the object program and the assembly listing. So after pass one only, you will be getting that header, record, text record, and record format. So that is what is done in pass one and pass two. So just write it in your notebook, pass one and pass two. So two pass assembler means it will have two passes over the source program, pass one and pass two. That is just doing two different scans on the source program. So please write this in your notebook. So do let me know after you complete writing it. So have you completed it? Okay, Yadu. Okay, Benhar, okay. So there are two passes, okay, to the assembler, pass 1 and pass 2. That is a two-pass assembler. Again, later we will see one-pass assembler as well as multi-pass assembler. For the time being, we'll talk about two-pass assemblers. So this is what happens in a two-pass assembler. We have the source program that is written in the assembly language. Okay. So pass one, it uses two different data structures, that is optab and simtab. That is operation code table and the symbol table. Then the output from that, it is an intermediate file. So after the assembler scans the source program, it is creating something that is an intermediate file. So something different from this. Okay, because some additional information you have got after scanning that source program. So an intermediate file is created. So that is what is going into the pass2. Okay, so pass2, it will again use symbol table and then it will create the object codes. Object codes that you have already seen, these are the object codes. Okay, so this translation is done in pass2. Okay, so that is what is happening in a two-pass assembler. A two-pass assembler, I told that the assembler has to scan the source program twice, but actually it is scanning the original source program once, and after that it is creating an intermediate file. That intermediate file is going into pass2. Then after pass2, it will create that object codes, which is used for the translation or the object program creation. So this is where the actual translation happens. This part means it will just update the address and symbol processing only. Translation is not done in pass one. Is it okay? I hope it is okay. Okay. So we'll see about two-pass assemblers in the, so I gave you an introduction to the two-pass assembler. So that's it. So we'll see again in the next class. So thank you for joining.